So our video for lesson 7.2, as always, if you're watching, especially for the first time, this is going to go a little quickly, so make sure you pause and really understand everything that's going on as we're going through it. Before we start, we've done distribution before. So this is kind of like the form that distribution follows. That we've done in the past anyway. If I've got something out here and then we've got two other things in here in parentheses, we're going to multiply this a times b, keep that plus sign, and then multiply a times c. So we would end up with a times b plus a times c. So again, this is just kind of like the form. So imagine that each of those letters were a number. This is just the pattern that we would follow. Down below, we see this with actual numbers. So if I had 5 on the outside and then x plus 3 on the inside, we end up with 5 times x, which is 5x, plus 5 times 3, which is 15. We're going to start going in the opposite direction of this a little bit too. So imagine going from here and kind of thinking backwards. That's what we call factoring. So factoring is the opposite of distribution. So for example, if I started with this, 3x plus 6, I might ask myself, what can I divide all of the terms by? And we usually want the biggest thing. And so if we're looking at this 3x plus 6, you might notice I can divide both of these by 3. And if you do, we say that we're going to factor out a 3. So I divide this by 3 and I divide this by 3, and we end up with 3 on the outside times the quantity x plus 2. So we'll come back to that in a little bit here. What's different now from what you've done in the past is we're going to have exponents. And we're going to be combining like terms in what might be a little bit different of a way. But the process is still the same. So for example, let's just look at part A. I've got negative 2x, so I'm going to multiply that by 3x, and I'm going to multiply that by 7. So that's what I've done down here. And so I've got negative 2x times 3x, keep my plus, and then I've got negative 2x times 7. When we simplify that now, the negative 2x times 3x, I always like to think of the numbers and the variables being separate. So negative 2 times 3 is negative 6. X times x is x squared. Plus, now I've got that negative 2x times 7, that's just negative 14x. And instead of writing plus a negative number, we should really simplify that into just a minus sign. Next, we're getting a little bit more complicated here because we've got higher degree terms. So for example, my term on the outside is 3x squared. And so now again, I'm just multiplying this by each term on the inside. And so I've represented that here. I always like to just bring these signs straight down. And then whatever you're multiplying ends up as your term in the middle. When we go through and do this multiplication, so 3x squared times 5x squared, again, just think about my numbers, so 3 times 5 is 15, x squared times x squared is x to the 4th. For some reason, students often want to put 15x squared here, even though we've got x squared times x squared, which would be 4 total x's. Pretty straightforward going on. I've got 3x squared times 2x, so that's going to be 6x to the 3rd, and my final term would be 18x squared. When we divide, the thing you need to remember is every term on top needs to get divided by the denominator. So for example, if we look down here, I've taken that first term, x to the 4th, divided by x squared, keep my sign, that term is divided, and that term is divided. So when we do this, we need to remember our exponent rules. So x to the 4th divided by x squared, remember that's like 4x's divided by 2x's. And we can think of every time I've got a 1 on top and on bottom, that's just a 1. So that just leaves 2x on top, or x squared. And again, we can think of the numbers being kind of separate from the variables. So in this center term, I've got 4x cubed over x squared. So that's like 4 over 1. That's just going to stay 4. 3x's on top, 2 on bottom. That just leaves us 4x. And in the final term, x squared on top, x squared on bottom, that just becomes 1, and we are ended up with 11. In part B, this is where we kind of need to use that factoring thing. We're trying, in most of these problems, you're going to notice that you're going to get something to, we often say, like cancel out, like with this x to the 4th over x squared. We often call it that, and it's just important to remember that what's really happening is it's just dividing by itself turns into 1. So we're looking to make that happen. And you'll often need to, if you get something like this, you'll need to factor that numerator and sometimes the denominator so that we can get that canceling out to occur, those matching terms. In this case, if we look at this and we think about what's the biggest thing I can divide 6 and 30 by, you might notice that that's just 6. So we can, if we think back to what we did up above here, right, if I started with this, we factor out the 3, we divide each term by 3, and we're left with this. Okay, so down here now we're factoring out a 6, so I'd have 6. This will leave me with y minus 5, and on the bottom we have y minus 5. And now, since I've got y minus 5 on the top and y minus 5 on the bottom, that just turns into a 1. Our final answer is just 6. So oftentimes, and you might just kind of notice this pattern like, oh, these look kind of similar. I've got y minus something, y minus something. And you might notice, oh, I can divide that by 6. That kind of thinking is going to be helpful with these types of problems. Multiplying. There's a couple different ways we can go about multiplying these binomials. So one way to think about this is just kind of like double distribution. All right, so I need to take each term here times each term over there. So one way to think about this is I'm going to take that first x, so I'm thinking about this x right here, and I'm going to multiply it by all of this. So I've got x times x plus 5, and now I've got plus 2 times all of this as well. So plus 2 times x plus 5. And then we can do the distribution and then simplify our terms. So x times x plus x times 5, x squared plus 5x, plus 2 times x plus 2 times 5, 2x plus 10. And notice it's always going to be, I should say generally it's going to be these two middle terms that are going to be what we can combine. Like those are what we would say like terms. So when I do that, I get x squared plus 7x plus 10. Final answer. Another method, and this might come in handy later on when you end up factoring things like this. It'll probably be a little while before you do that. But we have what we call the box method. So if I've got x and a positive 3 as one of my terms, I'm going to kind of put these in a box. And I've got x and negative 4 as my other set. What I'm going to do is I'm just going to finish up this box. And I know that each of these, so like this box now is going to contain my x times x. This box is going to be my x times negative 4, and so on and so forth. So by the end, we will have done each of these. And this is just kind of a nice way to organize it. So this would be x squared. This box is x times 3, so 3x. Down here would be negative 4x and negative 12. So now again, we've got those two terms that we can combine, but otherwise the rest is just going to have to stay how it is. So we've got x squared, negative 4x and a positive 3x, that's minus x, minus 12, and we're all set. And the final method, you may notice this is slightly different because we have 2x there instead of just a single x. but everything works exactly the same. Final method, and you may hear this a lot depending on who your teacher is in the future, we call this the FOIL method. So what this stands for is first, outside, inside, last. And that's just a way to kind of do this process to make sure that we don't forget anything. So first means I'm going to take the first term here times the first term there. So 2x times x. So that would be 2x squared. Outside, outside, that means the outside two terms. So 2x is on the outside and 5 is on the outside. Oops, didn't want that to happen. So that would be 10x. The two inside terms, that's going to be the negative 3 and the x. So that's minus 3x, and then last times last. So that's negative 3 times 5, which will be negative 15. So again, this is just a way of kind of helping us remember, okay, I got to do each of these times each of these, and this is a way to do that. So again, if we just simplify, I've got these two like terms, so we would end up with 2x squared, got a positive 10x and a minus 3x, so that would be plus 7x minus 15. So you've got a couple different methods. In our practice, it's going to ask you to use certain methods, so good idea to just kind of try some different ones, find what you like, and then eventually you'll just kind of be able to settle in and do whatever works best for you.